Okay, our second example is the differential equation y double prime plus 9y is equal to 2 cosine 3 of x. So first we need to get the homogeneous solution, and notice that the characteristic equation would be m squared plus 9 is equal to 0. So what's the solution to that? If you're good with working with complex numbers, you can almost think of this as a perfect square. The difference of two perfect squares. M squared minus a negative 9. And the square root of negative 9 being 3i. So it's going to be x plus or minus m plus, let me just write the solution down. That means m is equal to plus or minus 3i. I mean, you'll get that result if you just plug it into the quadratic formula. You don't have to remember all of your complex analysis. And remember what this is. That's really a 0 plus or minus 3i. And I think I called that alpha plus or minus beta I. The solution would be e to the alpha I, but alpha is a 0. So I don't have to worry about that at all. Times, so I'm going to get my homogeneous solution to be C1 cosine 3x plus C2 sine 3x. All right, so that's our homogeneous solution. Now for the particular, we've got the function g of x being 2 cosine 3x, right here. Well, what we would do, as the table says in the book, we would guess basically the sum of a sine and a cosine of 3x. But if you remember, let me put yp in there, y particular. You remember the situation where the particular solution has overlaps with the homogeneous solution? That's a problem. And in our case, it's exact. Constant times cosine 3x plus constant times sine 3x. And if you don't remember what you do, all you need to do is multiply it by x. So I left a little room here. And just to remind you, if the homogeneous solution had something that looked like a constant times x times cosine 3x, or a constant times x times sine of 3x, then you'd multiply it by another x, giving it an x squared. You do that until there is no overlap between the homogeneous and the particular solutions. So let me go ahead and box both of these in. Now we just need to find out what we need to find out what the capital A and the capital B are. Okay, so we've got yp, and I'm going to write it again here. Yp is ax cosine 3x plus bx sine 3x. And underneath it, I'm going to do all the derivatives down to the second derivative. So yp prime is going to be, I'm going to use my notes here so I don't have to think about it too much, negative 3ax sine 3x. Did I say that right? Negative 3ax sine 3x plus a cosine 3x. And then the derivative of the second one is going to give us plus 3bx cosine 3x plus b sine 3x. That's the first derivative, which we don't need in the equation up here, but we need it to get the second derivative of yp. And this is equal to negative 9a cosine 3x minus 3a sine 3x minus 3a sine 3x again minus 9b sine 3x plus 3b cos 3x plus 3b cos 3x. And 9 times yp, because we need that here, 9 times. I'm just going to take what's upstairs here and multiply it by 9. 9ax cos 3x plus 9bx sine 3x. And doing all the arithmetic here, we get y double prime plus 9y. Let's see. Let me just say that this, I'm repeating this, equals 2 cos 3x. Implies, using the substitutions now, implies, I'll go to the right here, negative 6a sine 3x plus 6b cos 3x is equal to 2 cos 3x. That's our g of x there. Okay, so we have a cosine 3x here, and we have one right here, but we don't have a sine 3x on that right-hand side, so this is going to be pretty easy. That means that this coefficient of sine 3x is going to be a 0. So negative 6a equals 0 implies a is equal to 0. And then, well, this will be simple. 6b is equal to 2. That implies that b is equal to 1/3. So our a and our b, if we plug them in, I get y particular with a and b solved for. A is a 0, so that term actually goes away. 1/3 x sine 3x. Only because a is 0 did that go away. So our final solution. Y equals, I'll go ahead and write it, y h plus y c, the homogeneous one plus the yp, the particular one, means that y is equal to this c1 cos 3x plus c2 sine 3x plus this 1/3 x sine 3x. And that's a solution. One important takeaway in this problem was our determination of the guess we used for the particular solution. Since it looked a lot like the homogeneous solution, and what I mean by that is there was overlap, we need to multiply this whole thing by x. And again, if there were still overlap, common terms, then we would multiply it by x again. And do that until you remove all the ambiguity, all of the common terms in YH and YP.